Hello everyone. Today I'm going to be showing you the ins and the outs of a plugin I've made. You can call it a plugin. It's it's a system that allows you to create telephone wires for your games. So this can be a hassle saver if you're a 3D artist and you don't want to take the time to extrude a bunch of cylinders or whatever in your 3D modeling application of choice, and you just want to do things quickly and easily in Unity, and if you ever need to change the positions of wires, this also makes it very simple. So we're going to go over from start to finish how to create the wiring you desire. The first thing you're going to want to do is you're going to want to locate whatever asset it is that holds your 3D telephone poles, and you're going to start by selecting the one you want. So if we drag all these out, in this case I'm going to select the small one, and I'm going to get rid of all the other ones. So I'll pull him out, delete the main object here, and now I have my small telephone pole. So next what we're going to do is make sure we have the tag wire point. So if you go into project settings, tags and layers, make sure under tags that you have the tag wire point, capital W, capital P. Alright, next what we're going to do is we're going to create an empty game object, and you can go into the side view or whatever view makes it convenient for you. And I'll go to wireframe here so things are a bit more visible. And we're going to position wherever the point is that our wire will be held up. And we're going to say, okay, give you a tag of wire point. We can even rename this to wire point. It's not essential, but if you just want to do that, then that may look better. So we're going to parent this to our small object here. And then Apple D to duplicate, or Command D should I say. And then I'm just going to duplicate this along the rest of the pole. So now I have 4 wire points. 1, 2, 3, 4. And that is actually it for the telephone pole system setup. So that's all I needed to do. Now I'm going to need a second pole that I can string to. So I'm just going to duplicate this, and I'm going to move him over to about there. And we'll use these poles, I'll use these poles to show off what the wiring system can do. So what we're going to start by, we're going to use wire system, wiring system, wire system, that kind of a thing. And now what we need to do is we need to, first of all, we need to make sure that it recognizes that our pole we have here is the first pole we want to use. So if we just drag that into here, then it sees, okay, it recognizes this one is pole 0, or the first pole in the array. So what we can do next, if we want to add pole 2, is we can just drag this into here, and we'll see we have our second one there. If we wanted to get rid of that, like say if we wanted to do a different pole, I could just hit X there, and that would get rid of it. So one way to do it is you can drag them in. The other way you can do it, which is pretty useful, is if you go under Parameters and you click Show Objects for routing, it will show all the objects that are in the main hierarchy here. So it won't show these child objects. It'll just show the ones at the top of the hierarchy and their origins. So we can see our second pole here, and if we click Add, it says pole 1. This is useful for if, oh, and you can also remove it from here. This is useful for if, like, say I had a long chain of poles. If I didn't want to get confused about them, about what was what, and having to keep track of which one to drag in next, then if I click Show Objects for routing, I can just very quickly click through these points, and I can add all my poles. And it'll show a line of what connects to what. So that's where that's useful, and you'll want to take advantage of that. So, add our own pole back in. That's pole 0. And we're just going to add the second one, which is this one, so we can remove all the other ones right now. And now that you know how to add poles, now we'll get into the actual stringing of the wires themselves. So what you're going to need first is you're going to need some sort of a decent material. So here I have wire material 2D, which is just basically transparent diffuse. If you want to, you can even add a little texture to this. And then we're going to go back to our pole here, and we're going to drag wire material 2D right into the wire material slot. Now you'll see it's checked that wires are line renderer. What this means is that if you get a material that's suitable on a line renderer, then that same material ought to be suitable on the wiring system. So keep that in mind. So with everything checked, we're just going to go down to functions here, click show functions, and then just hit auto route. And you'll see that very quickly, very easily, it has routed our wires from point A to point B. And we'll see if we change the width here, click auto route again, that it will change the width of our wires. If we wanted to do something else to it, we could either just keep hitting auto route. If we wanted to get rid of it, we can just hit clear routing, and then you can just auto route again. But this is all nice and whatever. But what if we wanted to make a more realistic wire layout? In that case, we would uncheck simple wire layout, which just strings from point A to point B, and we'd see a number of new parameters show up. So if we just hit auto route again, we'll see that it bent a little bit. So that has to do with the wire sag distance. If I set this to 1, I can get it to bend more, 2, even more, 3, and you can also set a random parameter. So if I set it with a random parameter of 2, some would sag more, some would sag less. As a general rule, you usually don't want to set this above what the wire sag distance is, otherwise you could end up with wires that are a little funky and do stuff like go over vertical, and that's not very realistic. So usually you want to set it to max or lower. But you'll notice something else, and that is that these wires, although they sag nicely, they're looking a little bit blocky. It's almost as if you can see the polygon. So to fix this, you can turn this up any number from 2, which would just look like point A to point B, to 64, which would look very, very smooth. But as you can see, if I go into wireframe mode here, as you can see, the mesh is super detailed. So if you're worried about performance, that might not be for you. So let's set it to some reasonable number, like 10. Alright, that's alright looking. So that's how to lay out with a sag. But let's say that you're going to have a game where the player will often come in very close contact with the wires, and in that situation, line renderers are going to look just cheap, and you don't want line renderers. Let's say you have a situation like that. So how do you go about fixing that? Well, the first thing is you're going to uncheck wires or line render, because we don't want line render wires. And if I just hit auto route now, you'll see that it looks really funky. And that's because we still have our material set to material that's for line renderers. So we're going to set this as some sort of basic diffuse. You can even use a specular, any sort of a 3D shader that isn't meant for line renderers. In this case, I'll go with red. And if we hit auto route again, we'll see that we get these red 3-dimensional wires, which up close look a lot better than line renderers. So what you can do here is I'm just going to set this to a very thick width so you can actually see what's going on here. These are creating triangles right now. They're creating triangular wires, and that's because the circle only has 3 vertices. In this you can set the vertices of the circle, and the higher you set it, the smoother it's going to be. So if you have really thick wires, you're going to want to set this higher. 3 or 4, usually a pretty good amount for thinner wires. So if your wires are something thin, I recommend setting it to that. Alright, so that's that. So there's another feature you can do, and let's say that you wanted to take up the realism of this, take it up another notch. So what could you do for that? Well, first of all, let me set the wires to something a more reasonable width. Okay, that looks about right. So what I can do in this case is I can check wires or cloth. And if I do that, you'll notice a bunch of sphere colliders show up at the ends of the wire. And if you go down to where the actual wire objects are stored, you'll see that they now use interactive cloth. So, if you're using interactive cloth, just as a tip, you don't usually need sag because it's going to sag automatically. So if I hit auto route now, and let me grab our camera and hit align with view so I can see what's going on here, and hit play. And you will see that the wires sag accurately. The one thing you might notice though is that up close you get these weird visual artifacts almost because the mesh is doing some funny things. So generally when using this, you don't want to use it with wires that you really want to see the complexity on because this probably will cause problems. But on wires with thin widths, like say we had 0.1 width, oops, I forgot to hit auto route. Hold on. Then it makes it less noticeable. And again, the higher you put this, the better the quality on the simulation is going to be. So I'm just going to set this to 3 since it's up so close. It almost doesn't matter, or they're so thin. And that's looking pretty good so far. So what you can do if they're cloth renderers is in this case you actually let me just do something. I'm going to throw a cube in here. What would happen if they were cloth renderers? If they're interactive cloth and we decide to make a rigid body cube land on the wires, you can see that it just pulls them down and sort of snaps them. So how do you change around the parameters? Well, since you can do multi-editing in Unity, which is very nice, you can just change, you can select them all, you can change the parameters here, and then it will carry over to all of them. So in this case, I'm going to turn up collision response to 1, and you'll see that the cube bounces off as if it were naturally colliding with a telephone pole. So if I turn this down even more, 0.5, then we ought to see sort of more of a springy motion. Of course, if you threw a heavy cube onto real wires, then you might notice that wires would tear. So let's try turning up the tear factor and turning down the collision response even more so that it'll sag greater under the weight of the cube. Nope, still not good enough. So let's clone him a few times. And then let's see how this does. We'll make him 5 mass. Now we start to see something. and you'll see that the telephone wires actually will tear apart. So, as you can see, with this system, you can make some rather realistic behaviors on telephone poles, and not to be everything you need. But we have one more scenario to cover, and that scenario is, what if you don't want to go through the hassle of setting up telephone poles? What if you just wanted to string from point A to point B to point C and not worry about all these extra wires? Well, let's go over to our hanging wires example. In this example, we have one game object here, one here, then one here, and here. So we have these wires that are hanging off the bottom of this cube, and we want to string them together. So what we're going to do is we're going to first start by adding all the extras. So he's here, so we'll add pole 1, pole 2, and pole 3. So I'm going to turn that off, and now we have all 4 connected together. So if I hit auto route, then we'll see not much happens. So let's go around and change our parameters like they should be. 3. Alright, why isn't it working? It's because on these hanging wire objects, they don't have child objects that are wire point tagged, and that's really where how the telephone pole system works. So what we're going to do, or the wiring system. So we're going to just click one parameter, which just says string across stop points only. And in this, it actually takes the objects themselves, and it's going to use them as the stopping points, not the wire points. So that's how to set up just a simple stringing across points. And that pretty much covers it. There's not much more to add about the wiring system. So if you think this would be beneficial to your workplace, it would be fun to have around, then you might just want to consider picking it up. And thank you for watching, and I hope this has helped you. Stopping.